Hi everyone, Miss Martin here. So if you are watching this, that means you weren't able to join us for the live chat, or you just want to go back and review some of the things we talked about today. So this is our big question, is what would happen if you screamed in outer space? That's our big question for this week. And our goal is I can explain how air helps sound move from one place to another. So let's review the assignment from Tuesday. The big questions were, what did scientists hear with their underwater microphones? How far can whales talk to each other underwater? How does sound travel underwater? And what are some experiments we could try to figure out how sound travels through the air? So here are the answers. So the first thing they heard was they were surprised to hear whales. Okay, and how far can whales talk to each other? They can actually talk to each other for hundreds of miles. How does sound travel underwater? It makes the water vibrate. So each little drop of water vibrates and shakes back and forth and shakes into the next drop of water and makes a chain reaction of vibrations. What are some experiments we could try to figure out how sound travels through the air? Well, what else could we do? I'm going to ask some other students during this part what we could do. A few people already looked ahead and saw that we could do something using balloons, or maybe I see people say you could talk through napkins and try to notice how the air works that way. So in the acted out experiment that I did for you through Edpuzzle, our big question was, how does sound travel? Okay, not just whispering in someone's ear, but yelling across a football stadium. How does that sound get from one place to another? So what could I feel with the balloon while my sister was talking? As I was holding that balloon, I actually felt the vibrations of the things she was saying. And I wasn't holding the balloon against her face, so it wasn't traveling through the balloon surface. It was actually traveling through the air first, and then going through the balloon, and then reaching my fingertips. Which noise created the largest vibration? When she popped another balloon, which was the loudest sound, I felt the largest vibration, which tells me the loudness of the sounds make bigger vibrations. So, if noise-making devices weren't touching the balloon, how did the balloon pick up that sound? In the first experiment we did on this, we had made our paper cup telephone, and the sound was traveling through the cup and through the string. So we know that sound can travel through things, through solid objects. We know that sound can travel through water. That's how the whales are able to talk to each other. But how did the sound travel from one place of the room to the other? So we're going to watch the video wrap-up of this. There's also a simulation, a model using people that we weren't able to do in class, obviously, because we're not in class. So let's listen in.
You create vibrations in your throat. Those vibrations travel out of your mouth and reach the balloon, making it vibrate too, even if the balloon is a few feet away. So sound vibrations do travel through the air. In fact, your ears work similar to this balloon. Inside your ear is a little part made of thin material, just like the thinness of a balloon. It's called your eardrum. When someone or something makes a sound, the vibrations from that sound go through the air, into your ear, and then make the eardrum vibrate, just like a drum vibrates when you hit it. Whenever your eardrum vibrates, that sends a message to your brain, letting you know you're hearing a sound. Now, you might wonder, if sound vibrations are in the air all around you, why can't you feel the air shaking? Or see the air vibrations even? Like if someone talks to you, or if someone plays music, could you notice someone's hair vibrating back and forth? Well, maybe the vibrations are just too small to notice. Maybe if we made the sounds louder, then we'd notice something. So let's see. Now, this person is going to hold a balloon over a speaker with really loud music coming out of the speaker. It's going to be just like the experiment you tried, but with louder sound. Now, I've turned the sound off so that you can just see what happens. You ready? Here we go. You see that? The entire balloon jiggles back and forth, so you can really see the vibrations. Now, let's see if it gets even louder. Here's a birthday balloon in someone's car when someone's blasting the radio. Now, this time I've got the sound on, but not so loud that it hurts your ears. You would not want to be in this car without ear protection. You can really see those vibrations, can't you? What happens if the sound gets even louder? Could the vibrations be big enough to... You know where I'm going with this, right? Keep an eye on this windshield. Watch as these people, who, by the way, really ought to be wearing ear protection, experiment with the vibrations from the really loud speakers in the back of their car. Now here's a close-up of the speakers. Watch what happens. That windshield is a goner. And here's one more time. This time, this person is wearing ear protection. And they've got an old car where they're going to see if they can deliberately make that windshield shatter as quickly as possible. Ready? Watch.
Ready? Here we go.
Whoa. So the vibrations from the speakers are traveling through the air and are actually making the windshield vibrate back and forth? Really? How is that possible? I realize you couldn't see inside this car, but I'm telling you, there's no big gust of wind going from the speaker to the windshield. All you could see is the speaker going back and forth and the windshield cracking and moving. Now, one way to figure out what's going on is to make a model that shows something that you can't see using things that you can see. So in a minute, you're going to do an activity. You're going to make a model that uses people to show how sound travels from a car's speaker, this person will act as the speaker, through the air, these people represent little sections of the air, over to a windshield and break the windshield. Now in this activity, different people will play different parts of the problem you're trying to figure out. If you're in a classroom, your classmates can play the parts. If you're at home, get members of your family to help out. I'll show you how to do this step by step.
So obviously we aren't able to do this in class, but I want to walk you through how they set up this experiment. We have our air blobs in the middle. We have the speaker, which is pushing the sound out, and then we have the windshield at the end of the line. So let's take a look. Our big question is this. Is as the speaker vibrates, which is a wobble back and forth, what happens to all the things in the middle, all the air blobs? So let's take a look at their demonstration.
Here's our idea. Speaker, wobble back and forth and push on the first air blob. Air blobs pass the wobble along until it reaches windshield. Give it a try.
You're more than welcome to try this part with your family. Okay, make one person the speaker, your siblings the air blobs, one person the windshield, and you can see that even if we can't see the air, this is a model to show that the air molecules, the chunks of air, are actually pushing into each other when there's a vibration. So, that's the big question.
Discuss as a group.
What would happen if you took the car to the moon where there is no air? Could you still break the windshield using sound? So we're wrapping it back up to what would happen if you were in outer space and you screamed.
When you make a sound, you really are making vibrations go across a distance. Now, in the case of talking into a string, or in the case of making a sound underwater, you know that there's some stuff or material that the sound is vibrating. The sound vibrates the string, or the sound vibrates the water. But when we're just talking to each other in a room, we don't think of sound vibrating anything. We forget the fact that there is a material around us all the time. Air. So what would happen to sound if there were no air? If there were nothing? Just emptiness. We could totally find out if only we could find a place without air. Can you think of a place where we could do that? Maybe you're thinking of outer space. There's no air in outer space, so we could do the experiment there. It's just a little hard to get there. Luckily, there's a device right here on Earth that can create the same condition as outer space. It's this, a device called a vacuum pump. If that makes you think of one of these, that's actually not too far off. This is a vacuum cleaner that uses suction to get dirt off your floor. Well, a vacuum pump is just stronger than that. Instead of sucking up dirt, a vacuum pump can be used to suck the air out of a container. So let's try it out. This vacuum pump is hooked up to underneath this little table so that it will suck all the air out of this space. If you put a bottle in here with a little hole drilled in the top so that air can escape, watch what happens when you turn the vacuum pump on. Ready? The vacuum pump sucked all the air out of the bottle, leaving it completely empty. That's actually what the word vacuum means. It comes from the Latin word for empty. So by turning the vacuum pump on, inside this jar, we've created the same condition as outer space, where there's no air. So what if we made a sound inside the jar and took out the air? What would happen? This is a bell. You hear that? Right now, there's air all around it. So let's take it all out. First, we'll turn on the bell, and then we'll put it inside a jar. Then we'll turn on the vacuum pump, and it will start to suck out all the air. Okay, it's sucking out all the air, so listen. What happens as it does that? You hear that? There's no air left inside now. The bell is still dinging. It's not broken. But you can't hear any sound at all. You just hear the sound of the vacuum pump. So if we put the air back in, what do you think will happen? Now the air is coming back in. Ah. You hear that? And the sound is back. So you can hear sound through air, but you can't hear sound in empty space. Why do you think that is? Why can't you hear sound in empty space? Well, if we think again of the idea that sound is a vibration, you can make sense of this. Because in order for there to be a vibration, there has to be something, some material or stuff, which is being vibrated. A string can vibrate, water can vibrate, even air can vibrate. But empty space? If we remove the air, then there's no way for sound to travel, because there's no material to vibrate. Sound is a vibration. If there's no material, there'll be no sound. Keep that in mind next time you watch a movie where you hear a spaceship blowing up, like this. Really, it should sound more like this. Silent. It's not nearly as exciting as in the movies. Stay curious, and see you next mystery.
Okay, so just a reminder to wrap up what we've been working on this week. So sound, it needs something to travel through. It's a vibration, so it works by one thing bumping into the other. In the first experiment, the sound vibrates the string. In the ocean, the whale sounds vibrate the water. In the room, the sound vibrates the air. So what would happen if you screamed in outer space? Since there's no air or other material for the sound to vibrate through, it would not allow the sound to travel, and there would be no sound. So we answered the mystery. So when we finish the video, go to your assignment and answer these questions. So first, describe how sound travels when you speak. So pretend you're talking across the room to your friend. And 2, explain why you couldn't hear anything in space. All right, thanks for joining me, guys.